Hey, what's up, guys? Chung here. So, so this time let's take a look at another LeetCode problem. Uh, 1060, missing element in sorted array. Uh, okay, so you're given like a sorted array of unique numbers, right? Which means there's no duplicate numbers, and you need to find the kth missing numbers starting from the leftmost number of the array. So, for example, right? So this one has like 4, 7, right? 9, 10. The 4, 7, 9, 10. So the first missing number from 4, starting from 4 is 5, right? Because the missing number here is the is 5, right? From 4 to 7, the missing number is 5 and 6, and the first one is 1. The first missing number is 5. That's why it's 5. And this one, for example, this one, the missing number 4, 5, 5, 6, and then 8, right? And then the third one is 8. And take a look at this one. So basically there are two scenarios here. So one scenario is the missing number is between the first element, the first number and last number. But in this case, the the missing number is outside of the boundaries here. So basically it's gonna be the 6 after the last number, right? So so for this issue kind of problem, I think the naive way is just do a unloop, right? A for loop. Basically, we loop each of the numbers here, and every time when you see a number, and we just deduce, we use the current number to subtract the previous number, and then we get the missing number, right? How many missing numbers, and then we just compare with the k, right? If this one, if it's less than k, then we know we need to keep going. We need to keep looking for the next uh, gaps until we see that okay, the current gap is smaller than the k. Sorry, it's greater than the k. Sorry. Then we know we find the final answer, right? And that's on the on time complexity because the worst case we need to loop through all the arrays here, right? And another uh, solution for this problem is the notice that you're given like a sorted array, right? And then you can use like binary search to find the kth missing number here. And so let me implement that the OM method first, and then I'll talk about how to implement the binary search. Okay, so for the OM, it's pretty straightforward. Basically, we have an answer here, and then we have a n equals to nums, right? Like I said, we start from the second one, right? In range uh, 1 to n, right? And then the difference, right? The gap. Let's calculate the gap. So what's the gap? The gap will be the nums I minus nums I minus 1, right? That's the gap because we need to also consider the number itself, right? So for example, the 4 and 7, right? Then what's the gap between those two? It's 7 minus 4, 3, right? But instead it's 3 plus 1. It's actually 5 and 6, right? 3 minus 1 is the 2, so which means it's 5 and 6. So what do? We do if the gap is smaller than k, right? It means that okay, so the numbers we need is not in the current gap. So we just keep going it, right? And we just re remove the gap between the current k. Else else we find, right? Else the case missing number is within the current gap. We simply return the nums I minus 1, right? Plus k, right? That's the missing number we need. But then for the second scenarios here, let's say if we after we loop through all the numbers, we still haven't found the case missing numbers. In the end, we do what? We simply return the the last number basically, right? The last number plus k, right? So whatever we left, right, in the k, we just need to add it to the last number. So I think this should just work. Oh, nums. Yeah, let's run it. Cool. Yeah. So yeah, this is like pretty straightforward. Like just loop through all the elements and we just check the gap, right? And now let's take a look at the binary search, right? So how do we do the binary search? So for example, we have 4, 7, 9, and 10, right? And the number we need to search is 3. Let's say the k and the k equals to 3. So how do we search it, right? So basically we search the index. So what index do we search? So we search the minimum index that until that index, the missing number until that index is greater than k. That that's the way we search the index. We do the binary search. So and for that we need helper functions to define like to calculate with current index what are the missing numbers until the current index, right? So let's say we have a current helper functions here. Let's say we have a current the index is like is 2 here, right? It's 1. This is 1 index. So for example, let's implement that helper function first to get the current missing numbers until this current index. So what's the current missing numbers until this current index? I think in the previous solutions, we kind of like get like an idea of it. So basically, the index will be the 7, right? The missing number will be 7 minus 4, and minus what? Minus this current index, right? Previously, we used the length and minus 1, right? Actually, the length minus 1 is the current index. It's the current index of this number. So 1 equals to 2, right? 3 minus 1 equals to 2. So how about 3? How about 2 here? How about 9 here? So the index of 2 is index of the 9 is 2, right? Same thing for 9 minus 4 minus 2 equals to 3, right? So basically, we're gonna use our binary search to find the smallest number that whose missing number until this index is it's either equal or greater than k, right? And then from there we can just use the previous number to calculate basically to look for the current missing number, the correct missing number. Uh, okay, I'll start coding and maybe you guys can take notes better once I finish coding here. So let's do a uh, get missing numbers number count, right? So and here's going to be the index, right? Index. We do what? Return the. It's pretty easy. We can also use a lambda functions to shorten the code here, but I'll just use a regular function here. Basically, the nums of the index, right? Uh, minus nums the first one, right? And then minus the index here, right? Nums. And then for the binary search, all we need a like upper bound and lower bound, right? So the index, right? Since we're searching the index here, the reason we're searching the index, not the number itself, is um, because the case missing number itself doesn't quite make sense in the context of the sorting array here. So the index of the case missing number makes more sense in this case. That's why we start from the 0. The index will be 0, and the right will be the what? The last index, right? Which will be the length of uh, and minus 1, right? That's the last index. While left smaller than not equal to right. Uh, do what? We do a middle, right? Just normal uh, index, normal binary search, right? And then uh, if, right? If this get missing num counts, if this thing is smaller than k, right? So basically, every time we have a missing number, we should compare with the k. If it's smaller than k, what does it mean? It means what does it mean? It means that the missing number is not enough, right? At the current index. So which means we need to move, we need to discard the current index because we know the current index will not give us the result. Then we know we need to move the left one forward, right? Middle plus one, right? We need to increase the index so that we can have more missing numbers. Else what? Else, okay, so we got enough missing numbers. Let's just try to move to the left, right? Because this one might be our result. And in the end, what do we do? In the end, okay, so once this is finished, the the right one or the left one. So the right one will be the first index that will have uh, equal than or more than case missing number, right? Then how can we find the case missing number in that case, right? We simply do we use the previous number. We use the previous number of this right here, right? And then nums right? And then we do a minus one. That's the previous number, right? And then we plus what? We plus the how many missing numbers we have until this missing numbers, right? And then we use k minus that thing, right? Right, minus one, right? So from these missing numbers and from this like previously numbers, what are the missing numbers? What are the difference, right? How many missing numbers we will need in order to get case missing number, right? And then that number will be our final missing number here. And oh, and one more thing. So since we have this example 3 here, we also need to check, right? Do a sanity check here. So basically, if k, right? If k is greater, let's say if the k is greater than the get missing number counts from n minus 1, right? From length, basically from here. If k is even greater than that, oh, let's do a n here. N minus 1, n minus 1. So if the k is even greater than all the missing numbers and for the whole array, then we know, okay, so the k's missing number is outside of the array. So we simply do a nums minus 1, right, plus k minus get missing number, just like what we did here in the end, n minus 1, right? Yeah, I think that should do it. Get missing number counts. Yeah, I think some typos here. Cool, yeah, it passed. All right. Yeah, real quick. So for the binary search, basically the difference here is that we search the index. We search the index, and then we search the first index that's have no less than case missing number, right? and then we just use that as a base point to go back to to go one number back, and then we use that number to calculate our real case missing number. Okay, cool guys. I think that's it for this problem. Thank you so much for watching the video. Okay, I'll be seeing you guys soon. Bye bye.